Geologists use many strategies to learn about Earth's past by looking at rocks. So one of those strategies is based on the law of superposition, and that law basically just says that when you have a rock strata, a bunch of layers of rock, the rock on the bottom is going to be older than the rock on the top. So for example, using this cookie in a jar, the flour layer, that would be the oldest. That was put in the jar first by the person that made this cookie in a jar. So it is the oldest layer. It is on the bottom. And the youngest would be the fudge. That was put in last into the jar. It's been in there the least amount of time. It is the youngest. Looking at an actual cross-section of rock, on the left here, you can see that layer G would be the oldest because it's on the bottom. It was created first. And then layer A would be the youngest. It's up at the top. Now, sometimes geologists will come across a very clean cross-section of rock like this cross-section on the left, cross-section A. But a lot of the time, things happen to rock that impact it. So if you look over at B, here you can see that a river has weathered and eroded away a bunch of that rock strata, okay? Similar maybe to what happened in the Grand Canyon. So that river has taken away a lot of the rock that was initially there, but maybe eventually the river no longer runs, and as a result, the new environment causes sediment to be laid down in two distinct or separate layers, okay? If someone were to come across this rock strata, they might notice, so it seems like layers G through A were laid down, and then H and I. So if you look down here in the center, it's a little bit funny because you have layers G and F, and then H and I, and A through E are missing, okay? Those missing rock layers are what we call an unconformity. So weathering and erosion created an unconformity in this section of rock. Here's another example. So initially you had one layer of rock laid down, and then 2 and 3. But something happened at time 4, some sort of weathering and erosion at location B that caused not only layer 3 to be worn away, but also layer 4 never formed. So maybe this was another example of a river being in that area. So it was flowing quickly over the rock, wore away one layer, and didn't allow a second layer to form. Maybe again, that river dried up. And so then you end up with this layer 5 forming in both location B and C. When you look at that rock strata in location B, you would say, there's an unconformity here between layer 2 and 5. There was additional rock at one point, but it is now missing. It must have been eroded away. Okay, quick reminder about fossils. Animals live, they die. If they get buried pretty quickly, they can form fossils. And so they end up deep in the rock strata. Sometimes they might be uplifted or put into a location where humans can find them. A specific type of fossil that we focused on are index fossils. And the reason why they are so important is because they give us information about the age of a rock. So index fossils, they need to be widespread, which means they needed, the organism that made that fossil needed to live all over the place. Think mosquitoes, all over the place. Abundant, okay, so again, like not only do they live in multiple places, but there are lots of them, like mosquitoes. And short-lived. I don't actually know how long mosquitoes have been around, so that might not be the best example, but an organism that didn't live for millions and millions and millions of years, they lived relatively short amount of time, so that when we find them, we can know the age of a rock, relatively speaking. So here, if we look at these 4 different types of fossils, Ammonite, Brachiopod, Trilobite, and shark, let's think about which of these would make the best index fossil. So ammonites, you will see there is one ammonite fossil in these 4 outcrops. So while it is not widespread, it is not abundant, it was definitely short-lived because it only shows up in one layer. Next, we'll look at the Brachiopod. So the Brachiopod, it was widespread. It was everywhere. It's in all 4 outcrops, and it's pretty safe to say that it was probably abundant because it's showing up in all 4 outcrops. However, it's not short-lived because, particularly like in the outcrop 2, you can see that it showed up in all 4 layers, which means that it was around for quite a bit of time. Trilobite is next. So if we look at where the trilobite is located, the trilobite is found in all 4 outcrops, but only in 1 layer. That means that it was short-lived. It only showed up for a brief amount of time, but the fact that we find it in all 4 locations suggests that it's widespread and abundant. This shows the distribution of all of these fossils, and again, it just highlights that the trilobite is the best example of an index fossil because it's showing up in all 4 outcrops, but only in 1 layer, 1 period of time. Okay, and then the only other piece for you to remember is that when we are looking at the past, the idea of modern transportation, airplanes, boats that are able to sail across the ocean, that's all very new in the past couple of 100 years, okay? Maybe a few hundred more than that, but super short in terms of the length of time Earth has been around. So when you find index fossils in different locations, or fossils of anything for that matter, if you find them on different continents, what that tells us is that land must have been connected at some point in the past when that particular organism was alive, because most organisms are not able to travel great distances across oceans. Some can, but most can't. And so the vast majority can, so almost none. That's another clue to the past that index fossils and other fossils as well can give us. All right, good luck on this week's Miser Me. Come to office hours if you need help.